Okay, today we're going to discuss integers and rational numbers and how we work with them and how they relate to each other. Now, integers are something we should be familiar with because they look a lot like our whole numbers, which start at 0 and work their way up the same way we would count. But integers also include the negative versions of those numbers, -1, -2, and so on. So when we look at a number line and we compare numbers, everything to the right is bigger than those things that are left of it. So we already know that 4 is bigger than 3 and 3 is bigger than 2 and so on. But when we look at negative numbers, it looks a little backwards. Because in this case, we see that -1 is bigger than -3 because it's further to the left on the number line. Rational numbers are related to integers because rational numbers are ratios of one or of two or more integers. So we start with 2 over 3. There's a rational number. It's the ratio of the integer 2 and 3. And any rational number can be expressed as just such a ratio. For instance, if I wanted to consider 0.5, that is equal to 1 over 2, the ratio of the integer 1 and 2. Even if I have a repeating decimal, that could be expressed as a ratio of 2 integers. So when we're looking at decimals, we can tell if they're rationals if they terminate or end, such as 0.5, or they repeat the same pattern over and over and over again. Those are both rational numbers. Now, if a number is a whole number, it is also an integer. And if it is an integer, it is also a rational number. Because wholes fit inside the integers, which fit inside the rational numbers. How about 0.6? Is that a whole number? No, it's not. Is it an integer? No, it's not an integer either. Is it a rational number? Can we write it as a fraction of 2 integers? Yes, it's equal to 6 over 10 or 3 over 5. That's a rational number. How about -2 and 2/3? Is that a whole number? No. Is it an integer? No. Is it a rational number? Well, if we convert it to an improper fraction, we get -8 over 3. So it is also a rational number. What about -24? Is that a whole number? No, whole numbers are only positive numbers, so it can't be a whole number. Is it an integer? Yes, it is. And since it's an integer, it must also be a rational number. Let's take some numbers and see if we can put them in order from smallest to biggest. So I'm going to give you 4 numbers, and I want you to put them in order from smallest to largest. So I'm going to pause the video, and you take a few minutes to put them in the order you think they go in. Okay. It may be helpful to draw a number line. We're going to space it out a little bit. 0, 1, 2, -1, -2. Now you might be thinking that 3.6 won't fit on this number line, and you're right. But since that's the only positive number, we automatically know that 3.6 is going to be the largest number. So let's think about where the negative numbers fit. We know that negative 1.5 has to be halfway between negative 1 and negative 2. Negative 0.31 would be between negative 0 and negative 1. And negative 2.8 would be somewhere over here past the negative 2. So when we're looking at numbers from smallest to biggest, smallest are all the way to the left and biggest are all the way to the right. So we just work our way through the list. Negative 2.8, negative 1.5, negative 3.1, or 0.31. There we go. Now there's something else I want you to notice on the number line. When we draw our number line, normally we use 0 as our reference point. And 0 is the perfect division between positive and negative numbers. But I want you to notice something. 4 and negative 4 are the same distance away from 0. And since they're the same distance away from 0, but on opposite sides of the number line, we call them opposites. 4 is the opposite of negative 4, and negative 4 is the opposite of 4. So, if A equals 2.5, then negative A equals negative 2.5. And if X equals negative 7.1, then negative X equals positive 7.1. Because those are the numbers that are on opposite sides of the equals line. We use this concept to define what we call absolute value. Now, the absolute value of a number relates to distance. And distance can only be measured in positive numbers because you can't get in your car and drive negative 3 miles. So generally, we're going to be talking about the distance a number is from 0. Now we know that 3 is 3 units away from 0. But what about negative 3? Right, that's also 3 units from 0. So the absolute value of a number, really, we just make it positive. The last thing we want to look at today is a conditional statement, or an if-then statement. An if-then statement has a hypothesis followed by a conclusion. And in order for an if-then statement to be true, whenever the hypothesis is true, the conclusion has to be true. If the hypothesis is true and the conclusion is false, then we have a false statement. For example, if a number is rational, then it is an integer. So, if we want to prove this false, we need to find a number that is rational but is not an integer. So let's think of some rational numbers. 3 is a rational number. That's also an integer. Negative 2 is a rational number. That's also an integer. 1/3 is a rational number, but it's not an integer. So 1/3 is a perfect counterexample for this statement because it is rational, satisfies the hypothesis, but does not satisfy the conclusion. How about this? If a number is rational, then it is positive. Take a minute and see if you can come up with a counterexample to prove this statement false. Any negative number will work. Any negative rational number, such as negative 2/3 or negative 7. Those are both rational numbers. They are not positive. So those are perfect counterexamples for our conditional statement. That ends lesson 2.1. If you'd like, you can go back and watch the video again, or you can start on your homework.